Hello everyone, welcome to my channel. Today we will discuss certain problems from chapter number 20, formation and reaction of enols and enolates from Claydn book as well as from the Clayden Solution manual. Now let us start with a simple problem. In this reaction, a ketone is given and we have to react with bromine and acetic acid. Okay, so the first step will be the lone pair over the oxygen atom is going to abstract a proton. Okay, then there will be generation of negative charge and acetate ion is going to get removed. Okay, and we are going to get OH and a positive charge will be on the oxygen atom. And then since positive charge on the oxygen atom is not stable as it is an electronegative atom, so in the next step this bond will break and it will go there, and further a hydrogen atom H plus will get removed and there will be a bond formation and we are going to get enol. So this is an enol. We are going to get an enol from here, and then in the next step bromine is there, so the lone pair on the oxygen atom is going to get here and it will attack on the bromine, and one bromine is going to leave and we are going to get a positive charge will be again in the oxygen atom and there will be bromine. Okay, and the next step this H plus will get removed and there will be no positive charge. Okay, and we are going to get this product from this reactor. Now let us see our next question. So in this reaction, what are the products formed? First of all, it is a ketone and a base is given, that is, let me show it as B minus. Okay, then the function of base is to abstract a proton. Now 6 hydrogens are available here, so let me consider this proton is going to get abstracted. On abstraction of this proton, there will be a double bond and there will be a negative charge on the oxygen atom. This O minus double bond and it is an enolate. Okay, this is enolate system. Then in the next step, this is a alkyl bromide or alkyl halide, I can say you. So whatever alkyl halide, it is ethane bromide and it is a acyl chloride. Now let's see how the further reaction proceeds. So whenever you see an alkyl halide type of system, this negative charge is going to get back and this pi bond undergoes nucleophilic attack at this carbon, and since bromine is a good leaving group, it is going to leave and it will give us our product as double bond O. Here two carbons are there, ethane group is there, so this will be the product in this step. Now when we react this with acyl chloride or you can say acid chloride, then this mechanism is not followed. Instead there is a negative charge. This is enolate system. This negative charge is going to act as a nucleophile and attack at the carbonyl carbon. The negative charge will be in the oxygen, it will come back, and chlorine being a good leaving group, it will leave and it will give us our product as O double bond O methyl group and here a double bond. So this is the product formed in the second time. Now why this reaction occurs like this in case of acyl chloride, and the reason behind it is that the reaction is dominated here. It is dominated by charge and electrostatic interactions and also due to domination by orbital interactions also. Okay, as given in the Claydn book. So you just keep in mind that when there will be an acyl system, mechanism will proceed like that, or even if there is acetic anhydride, then also the same mechanism is going to proceed. But in case of alkyl halide system, this carbon is going to act as a nucleophile and it will give us such products. Okay. Now let us do our next problem. So in this reaction, what is the product formed here? Okay, this is a carboxylate group attached to this cyclohexane. Then on reaction with NaNO2, this is sodium nitrite and H2SO4. Okay, sulfuric acid. So whenever sodium nitrate is added with an acid, then it generates NO plus, okay, or you can write it in the form N double bond O positive charge on the nitrogen atom. So it is going to generate this electrophile first, and then just think how the reaction is going to proceed further. For that, let me write this carboxylic acid group again, C double bond O OH. So how it is going to attack this electrophile? For that, we have to convert this into an enol form. How? There is a hydrogen available here, so this hydrogen bond will get here, H plus will be removed, and there will be a negative charge, and this negative charge is going to attack, that is, it is going to in the enol form. Okay, convert it first in the enol form so that further reaction can take place. C OH OH. Okay, first step you have to convert it in the enol form. Okay, this is an enol form. Then reaction can proceed further. This lone pair on the oxygen atom is going to get a bond from first bond, and this acts as a nucleophile and then attack the electrophile, and we are going to get our product as N double bond O, and here C double bond O OH positive charge and OH, and the next step this hydrogen is going to get removed and there will be no positive charge, it becomes neutral. So this is the final product. No, this is not yet the final product, because it can undergo a cyclic mechanism. I will show you. And double bond O, and I can write it, this carboxylic acid in this form, and then a cyclic mechanism will occur now. The lone pair on this oxygen atom is going to abstract this proton, and this bond will come, there will be negative charge. Further this negative charge is going to get here and form a bond, and again there will be a negative charge, and this bond will again, this negative charge will again come back, and there will be generation of negative charge. Okay, it takes place in a direct step, but I am going to show you step by step. And double bond O H positive charge, right? So there is a negative charge, this will again come here, and this positive charge is further neutralized, and we are going to get our product as double bond N OH. We are going to get an oxime. Okay, so this is the final product of this reaction. Let us move on to this question. So in this reaction, what are the products forms? In the first reaction, it is given a primary amine, or you can say 1 degree amine, and it is a 2 degree amine, second degree amine, right? So how the reaction going to proceed here? See, I have discussed in my previous video only that whenever an amine system is given and a double bond is given, just if you don't even know the mechanism also, you can do like this. Here it is an aldehyde, right? So just remove this oxygen atom and this 2 hydrogen, water is going to remove. In simple way you can make like this, and a pH will be there, and it is going to give us an imine system. So the product of this reaction is imine. Now for the second one, you can also think as such, and the double bond will remain like that, and attach it with the nitrogen given and make it as such. 1 2 3 4 5, yeah, but 4 bonds are, so there is a generation of one positive charge on the nitrogen, and it is iminium ion. Okay, since positive charge on the electronegative atom, so it is not stable, so further it can undergo one more step. This hydrogen H plus is going to get removed from here, there will be a bond, and this positive charge will further neutralized, and we are going to, sorry, there is a hydrogen, and we are going to get this product. Okay, this was the shortcut way to do it, but if you want to know the mechanism, then the mechanism occurs like this way. There is a carbonyl system, right? So pH and H2, first of all the lone pair is going to attack the carbonyl carbon, and there will be negative charge, and HPH, one proton will get removed, and there will be O minus, one proton is going to get abstracted, and again this lone pair is going to attack here, and form double bond, and what OH is going to abstract this proton. Okay, and we are going to get this this product we are going to get. Okay, so the mechanism proceeds here like this way. Now let us move on to this question. So in this reaction, what are the products formed? So firstly, so you can consider this one as Rx, no problem, right? It is the group R, and it is Rx is bromine. Okay, now when Rx is react with magnesium, then a reagent is formed. What is it? RMgX. What? Grignard reagent or not? So Grignard reagent is formed first, that is MgBr is formed in the first step, and then phenyl cyanide is given, right? That is, I can write it C triple bond and. So here Mg is partially positive and this carbon is partially negative in charge. Delta minus is going to attack on the carbon and negative charge will be on the nitrogen atom. Okay, so we are going to get a carbon, there is a pH and double bond, and minus, this minus is again going to abstract a proton further, it become NH. Then the next step, hydrolysis occurs. So whenever you see a double bond and imine type of system on hydrolysis, just do one thing without even knowing the mechanism. You can do one thing, just put this double bond and an oxygen group. Okay, so this on hydrolysis we are going to get this product here. Then bromine in presence of acetic acid, we have already discussed this one. First of all, the hydrogen is present here, so this will go here and enol is going to get formed, and also there is acetic acid, so this negative charge can abstract this proton. First of all, enol will be formed, and the next step, attack on the bromine will occur, and the bromine minus is going to leave. Okay, so we are going to get double bond O, H positive charge and pH, and in the next step this H plus is going to get removed and we are going to get our product as this one. Sorry, I forgot to give the bromine only. So this will be the final product of this reaction.